Hello, in this video we're going to continue our Loki compiler. And so what we did in the last video, we did create a simple tokenizer which has a bug on string literals, and we are going to fix that. So if we run our yes, let's just use this. So if we run our test case, and CA is for just cargo test, it will give us, so for each so this is basically a simple state machine. So for the last double quote, we go to state number 7. So what is a state number 7 is this. So if in the state number 7 we have something, and this is, and the type isn't a string literal, so if we have some token and we don't have a string literal, we cannot create string while in other token, otherwise we add this. So what is the problem? The problem is when we have the semicolon in here, if the last token we added so if the last token we added is a double quote and the character is not a double quote, the current character, what we are going to do is this. So we need to make this check a bit more complex, because we need to check if we already ended the string literal. So there are multiple ways we can do this. There is actually one way to do this in a better way, and that's that. Maybe let's do that. So instead of doing this in here, when we reach in the state 7, if we already have a so let's just do else if. So else if current token is something, and also current token on wrap it, type it is token type string literal. If we already inside in a string literal sorry, if we already inside a string literal, what we need to do is we just end the string literal right now. Then this is an else. So I really like the X that selects lines. Current token moved because I need to clone this. This is not the best way to do this, but who knows. And I'm actually really loving this Helix text editor. Really kudos to the creators. So so if it is a string literal, we just want to end this. So I'm going to do is tokens.push current token dot unwrap, right? I'm gonna clone this and also add another add another token for the semicolon for the double quotes. So basically with this, let's now run this. We get an error again, one failure. What happened in the case of we wait into state 7? I think I found what happened. After this, I need to also do current token equals none. So I empty my current token. What about now? We also failed. Why? Okay, so let's see. print line ending string literal. Let's see if we see this. Yes. So we ended the string literal. So after this, at the first check, our last, yes, we also go into this, and current, no, we cannot do this. We need to do other thing as well. So what we need, this double quote start and double quote end. I think this would fix our problem. So what we need to do is to say that last one is start. Last token we emitted. And the other thing is in here. So when we are ending this, we should add an end. And this is an end. When we are in here, this is an end. No, this is not necessarily the end. The end happens in here. So this is actually the start. We also probably have errors in here, right? So this is the start. This is the end. Let's run the test. And yes, so we passed all the tests, which is nice. So our code now is handling the assignment for strings as well. Okay, so we have assigned numbers, assigned strings, everything is passing, which is nice. And we are parsing tokens. I can also add something else for function string token. It's probably going to work, but let's also just copy this in here, save this. So token is, for example, this. I assume it's going to be, it's not going to be one token, of course. So it's going to be token type is token type double quote start, value is just double quote. I'm gonna change this. This is not wise to have this kind of memory when we never use this. I mean, I know what is the value of a double quote. I don't want this in here, so save it. So what's the while parsing the struct? What's the problem? Oh, this is the problem. So token string literal, and this is this, and token type is token type double quote and value string from okay. So let's see if this passes. This should pass, of course. Yes. So this is cool. So let's see what are we handling now. I'm gonna just rename this to be how I can rename something. Rename symbol. So I'm gonna just rename this to assign operator. Let's have a better naming, right? So this is an assignment operator. Cool. So let's do a commit. Fix test failure. So let's go here. So what we are parsing is a simple assignments, but if we take a look at the spec, we see that we have slices that we are not parsing, and we also have some constructs for the. So let's start with so we are parsing this, and so I'm gonna do these slices. I'm gonna do slices. Let's hope this works. So what I'm going to do for slices is character is. So if we are at the start, what I'm going to do is if the current token is something, what I'm going to do is tokens.push current token dot unwrap, and it also needs a clone. Maybe I should use an RC for current token, I don't know. We should investigate this later. So let me actually add the comment in here. Can we, or let's just try it to do, can we use RC option token? So I'm gonna push this into here. Also, what I'm going to do, I'm gonna make the current token empty. Also, what I'm going to do is tokens.push token type is token type. Let's open SQ bracket, square bracket, open, a square bracket, close, and a square bracket open. Okay, let's just do this now before we make it any further. So the value is an optional thing, because many times we don't need a value, right? We don't need this value. Okay, so no, there is no method. Okay, so I'm gonna add this as a sum to fix this. This should fix. So do we need this, for example, for semicolon? No. So value is just none. In here, value is also none. Let's take a look at in here. Okay, this is a string, we need this, so this is sum of something. This is a number, right? Yes, so this is also a sum. And this is also none, because we know the value already. This is and this is none as well. Okay, so the only problem is here. Okay, so token.value, so let's say if the token value is sum of string sum of s, I'm going to do s, not s actually, s dot s. If it is none, just do string from, not actually string from, just c dot to string I'm gonna say okay. Okay, I want the exact same thing for here. This should also this should all get passed. No, because we have a lot of errors. How we didn't see them? Oh, we have the same thing. Can I copy paste this? Copy paste the match, this one, and paste this right in here. Why this is, oh, okay. Cannot consider borrowing. Mutable. Okay, we have a lot of errors in here, so I'm gonna say this is a none. This should be also 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 none. And this should be also some. And actually I did this wrong because this shouldn't be a none. This should be sum of a string. Value is none. Value is none. These are some. This is a sum. I don't need this. This is a none. This is a none. This is a sum. Okay, this is also sum. Okay, is there any other error? Okay, yes. So we cannot use this. This should be a mutable reference to this. This should be also mutable. Okay, this should pass. Okay, so I'm gonna do another commit and say that do this commit saying make value in token type optional. With better memory use. I mean, it's obvious we should do this from the start, but so let's actually, okay, so when we open a bracket, if we have any token in progress, we just push it, we add a new token, and we made the current token null. If we also have this, if we have a token in progress, we push it and we do this. And remove this, remove this. This is just the close. Okay, so C open and C close. So what would happen if we add something in here? So we have X, assign operator, number, and we do none, right? Yes, yes. So we do assign operator, do X assign operator. Okay, where am I? Why the scrolling is so bad? So we have X assign operator 1 2 3. After this we got the token. Type is token type skew bracket open, and the value is none. We are going to have almost the same token. Paste this right in. And close. And I'm gonna put actually something in middle of it. For example, a number and a string. So we are going to have something in between. So I'm going to have this number which is going to be 1 2, and also this token type string, not a string, oh actually this is a string, and strings are hard because what we do is double quote start, the value is none, maybe we should move this to another test case. I don't know, I think this test case is so much big. I mean, when it breaks, I don't know where to fix. Value is going to be name, needs to be a sum as well. There's also this token type double quote, and value is none. Some string from. Cool. So will you work? Yes, failure. So what's the problem? Oh, we go to state 4 for these? How? How is this possible? Why we are going to state 4? So we have, so let's look. So we have 1 2 3, then we start. How we go into state 4 for start? I mean the current token we already have after this is some. Okay, this is not this, of course. Is that in between? And it's not underscore. So why you come down? There is a simple way to fix this, because these are being get run by order, but the string thing is also should be on top of these two. So what we should do, this is weird that these come down here in state 4. I don't get this why. So 1 and 2 are going to state 6. What is the state 6? These are numbers. Okay, numbers are okay. We go into 6. We hit a comma, which we didn't anticipate actually. So what we should do is comma actually, and just add this at the bottom for now. Else if C is comma, you just do almost the same thing you do for these. Okay, run. For comma we go into print line comma state. Close SQ bracket. So what is this state named? What should we name this state? So if this is a character or an underscore, I want this to be ident, right? So I want this to be identifier. Or we have a token already, and the token is ident. It's probably this. So let's see. State 1 is semicolon. Also we have this state which is inside string literal. Let's run this again. Okay, so X is an identifier. Space character is space, current character is this, so we are assign space. We are in number. Then we go into an identifier, and I don't know why. I mean, I think I know, because this is probably because what was the character? Open. Okay. Open square bracket is probably A, and open square bracket is less equal than Z. Let's run this. So let's run it. So okay, so let's run it. Both are true. So aren't these ASCII characters? ASCII Charles. Aren't these ASCII? Is UTF completely different? So yes. Oh, really? This is actually weird. I thought that they are after each other, but so you see, we have uppercase letters, then we have brackets, and then we have lowercase ones. So this is actually correct, and we should also check in here that C is not open and C is not close. I thought that we have a problem in our algorithm, but this is actually right. Okay, failed. So why now? So open square bracket, we are again in number, then we have comma, we have space, we have double quote start, inside string literal, double quote state, ending is string literal, close, semicolon. Okay, so test assign number failed, of course, but why is that? Let's go down, down, and let's actually print line tokens. This should be probably debug print. Finally, okay, so we have this identifier, then we have a sign operator, then we have a 1, 2, 3, then we have an open square bracket, then we have 12, then we have comma, then we have double quote start, then we have a string literal of name, then we end it, then we close the square bracket, and then we have finally the semicolon. I actually think this is right. So identifier assign number, right? Assign number. Then we have a square bracket, open. Oh, we didn't have the comma. That's probably the reason. So in here we also have a token called type is token type comma, and the value It's just none. This should probably run. Right. So we actually have a complex thing in here. This is test assigned number mixed with SQ brackets. It's actually a weird test case, but we actually added the square bracket. And actually we have the slice, you know, we already have the slices. So actually let's add another test case for slices as well. So basically a slice is nothing other than we already add. So test slices. Test slices. So what we do is test what I want. So let me actually copy it from this. So can I do v match inside function? So this is actually, I'm learning about this editor, and the three-seater query were really nice. There's, I think, one wrong. This should work. So now instead of this, let's have a normal one. So we don't have the number thing in here. We have a square bracket open, number, comma, double quote, semicolon. This should run. This should run. Yes. So now let's commit feature slices support in tokenizer. So what's next? So we have slices, we have default values. We also can do like this. So should we do this or not? I don't know. I don't know. I really don't know about this. Slices, right? So should we have a token for interface? Probably. So okay, is there any other really weird thing we should parse? No, most of them are keywords from now, which is actually nice. Do we have a network connection problem? Not likely. No. Did you do that? I don't know. So what should we do next? We should go for keywords. Where we should add keywords is inside the identifier state, actually, because that is probably what we should do this. So where's the identifier? In here. So when we are doing something really weird, identifier slash keyword state. So what we should do is if current, okay, so what we should do is if current token is something, we have a value inside and we have a value inside it, right? If s equals, so s is a string, for example, if, right, what we should do actually, we should say tokens dot push, we reached an if, tokens dot push a token, and we should add if keyword token. So the type is going to be token type if keyword, and we should actually continue the loop, you know. In here we should do is continuing the loop. What is these? The we don't have a value, it's none. What is this problem? Unexpected token. Yes, because we don't do this. Okay, so if there's nothing, just add this to it. This is the state we should check these. Else if s equals, for example, interface keyword. We should also have for structs, so struct keyword. We also have struct keyword. Let's have this for now. Let's make this work as well. So okay, it's in here. We should have exactly the same thing and continue. Okay, we also have the exact same condition. And this is a struct. Okay, so we also need to support curly bracket open and curly bracket close, and we should do where are they in the ASCII table? Yes, if they're after these, so we can safely ignore these and add them right down here. And actually we should just copy it because they have basically no what I'm going to do is to close this and add this in here. So we have this is this open curly bracket open curly bracket open curly bracket close close. And finally we have the comma state. Okay, run the tests again. Cargo test, there should pass. Cool. So let's add new test cases for assigning a struct to something. So test is function test assign struct. We should be able to parse these. Okay, what I should do is get one of the simple assignments which we have. Not this one, this is a hard one. Why my scrolling is so weird, I don't know. Okay, for example, let's get this one. So let's do match inside function. We copy it, we go here, we paste this, and we rid of this. Okay, so what I want to do is to assign something. Oh, a struct is hard, and I'm gonna tell. No, it's not hard. Okay, so X is a struct like this, right? We already know that we are handling a space. Okay, so cool. Let's actually make our string test a bit harder. So let's add a spacing here, and also here, and also here, to make sure that we are handling any kind of spacing anywhere, hopefully. Okay, back to our test case for struct. So X assign operator, double quote start no, string literal no, double quote end no. So what I want is a token type struct. So struct keyword value is none. If I can type token type curly bracket open, the value is none, token type curly bracket close, value is none. Can we parse this? Test assign struct fails, which is okay. So we didn't actually fail. Yes, so we didn't actually test the assign string, which is cool. So we are handling the space okay. So we have struct. Oh, how? Why we are doing this wrong? Weren't they? Should we check this in here? How we are going to into identifier state? I mean, this is necessarily. Will this fix this? Let's see. So if C is not a curly bracket open, and C is not a curly bracket close, let's run the test again. Okay, at least that's not the problem, which is nice because I know this is not. Okay, so we are inside, we are getting inside, but this is not from this is not this. So we are already an identifier, right? Right, we are already an identifier, but our identifier does not mean that we are necessarily an identifier. So maybe we are just wanting to parse, you know, really, maybe we just want to parse a, you know, for example, type open bracket. We are this is actually a case we should handle. I don't know how, but maybe we should just put the brackets and stuff above this, because an identifier cannot contain these characters. So maybe we should just handle them up. What is after this is a space and double quotes and everything. Maybe this is actually a wise thing to just handle these above. Nice. So are we passing? No, we have only one fail, which is the struct. Okay, so we have now open curly bracket, close curly bracket, and semicolon. So I think I missed the semicolon, right? No, we didn't. So what's wrong? Struct is a keyword. Let's actually print the tokens and see what's what. Print line tokens. Identifier X, assign, struct keyword. Okay, that's the problem. So we already we also added a struct as a identifier as well. Why is that? So when we do the identifier keyword, we push this. If it's a struct, we continue the iteration, right? So the next, every time we should actually make this empty. Yes, so we should make the current token none. Yes, it should pass now. So add this, commit, add struct interface if keywords. This is really easy. Actually, let's add for loop as well. So else if s equals 4, we do tokens dot push token type. Let's add this in here for keyword. We actually are closing in on actually finishing the tokenizer. Current token is none, and continue. We should also be able to parse a. So we have the same thing for, where's the struct test slices, where's the struct assignment? Test assign is struct. So yes, just paste this. Test assign interface. This is also a test. X equals an interface. Interface. We should be able to also assign the if x equals. Actually, we cannot test ifs as good as other things right now, so let's just ignore these. Run test and add test for interface. Actually, we may be able to parse interfaces. I don't know. I don't know how we are handling the new line, but I think it's okay for now, for this video. So we are already closing in. We just need to add the syntax for colon, which is for types. We use for types, and should we use colon everywhere? Maybe everywhere, yes, maybe that's a good thing to have for functions as well, because in my spec I don't use colons in here, struct definition and in function definitions, but maybe this is a good thing to have this as, you know, some unification of the syntax. So I should probably have a colon, and let's just do it. let's just add so first of all, we for interfaces and everything, we should handle new line. So new line is in the same category as basically as a space. So where is the space? Okay, so else if it's a space, or C is a new line, what we do is just push the token, we have space or new line. Okay, this should make no change at all. Yes. So now what we should do for an interface, let's just create this. So for both struct and interface, yes, in here. So what I need is a new line, and after that I'm gonna say a tab character, and then I'm gonna say, for example, y is an int and a space in it. Something like this. This should get parsed. So where is this? Where is the space? Space. Not the space. Oh yes, because I want to handle the tab character as well, as basically getting ignored. Okay. And colon is also in same category as semicolon. So where is the semicolon? Semicolon in here. Okay, so this is colon, this is colon, and this is colon. Okay, I did wrong. Cargo test fails because test assign struct fails, of course, because we did change that, and I know that this will fail because, so what would we have? So we have x assign struct keyword open curly, identifier y cool colon, okay, identifier integer. Okay, so that is y. When we have a new line or space or anything, we should empty the current. So in here we should empty the current token. So why we didn't when we had a new line after? So we have int current char is a new line. You're still in a okay, this is also a problem with this probably, right? Where is the new line character? Where is the new line? Okay, so for some reason when we are in a identifier, the new line is not handled. So should I do this? Or okay, we are changed. C is not tab and C is not new line. Now what? So what is the type? Yes, it's an identifier, int, close, and none. And actually I want to add int and actually all types as tokens. It's just less memory and easier to read. So add this in down, int keyword. So when I'm parsing this, I should do same for this if it's an int keyword, make the current token none. Okay, I think I missed one. Cool. So we have the int keyword. So in test assign struct, test assign struct ident x sign struct curly open. In here I should do token type ident value string from y token. This should be also sum of this token type colon value is sum, not sum, none, and finally token type int keyword value none. Run. X none. X assign. Oh, interface. Test interface failed, right? Yes, because because of why? Because we are so what? Okay, that is a hard thing. Okay. Okay, that is a hard problem. Am I right? So we are parsing int as a keyword, and we also have interface. But the problem is in this loop, we always, when parsing interface, we get to int. This is a hard thing, but I'm tired to fix this. So maybe we need to change a lot. So I'm gonna just stop here and I'm just gonna call it. And if you like this content, of course, like and subscribe and comment me Twitter, and you can mention me on Twitter or anything, email and other communication things, and please like and subscribe and to make me happy to continue. So thanks for watching, and until the next video, goodbye.